So yesterday, we actually learned that we can take the sum and difference of functions, and the sum and difference of functions could come at you in the form of like equations. And then you would just add your equations and you get a new function, right? And then we explored the idea that if we're given a number, the x value, whatever that x value is, the x value maintains itself, and we just have to find the corresponding y value. You can get a y value from an equation, you can get a y value from a graph, you can get a y value from an ordered pair, but regardless, when you say h of x is equal to f plus g of x, it's just h of 4, because the x value was 4, is equal to f of 4 plus g of 4. The x value maintains itself all the way through. We found that f of 4 was 1, g of 4 was 3, so h of 4 was 4, right? And so it's basically just if you have an x value, substitute it in and find the corresponding y values. And then the big idea that really mattered in terms of like high-level thinking is you can't add or subtract a graph if it doesn't exist there, right? And so yesterday when we were doing this task and we were finding h of x, which was f minus g of x, f of x had a lowest value of -4, and g of x had a highest value of 0, which meant if I'm adding the f of x minus g of x, I would start at x equals -4, and I would stop at h equals 0 because I cannot add does not exist on, right? And a common mistake people make is they're just so tempted to turn this into a quadratic, and they just want to keep it going. And as soon as you do that, you broke math. You tried to add something or subtract something that didn't exist. Your function is limited to the domain of each of the functions you're adding or subtracting, right? And then that was kind of summarized in this table, right? So when I looked at g of x was x is greater than or equal to -5. F of x was x is less than or equal to 3. If you're going to put them together to get your h of x, you're stuck between those two x values. Like you can't add something that does not exist. You cannot subtract something that does not exist. So that's like a big idea, and that idea kind of carries forward with us until we get to rationals, where we know that there's non-permissible values that go into that. Now, when I say product, you guys need to think multiply. When I say quotient, you need to think division. So consider the functions f of x is equal to x minus 2 and g of x is equal to x plus 2. You guys should recognize that these are both linear functions. They're degree 1 polynomials. So it says determine the equation of h of x if h of x is f times g of x. So another way of writing that would be h of x is equal to f of x times g of x. Make sure your multiplication symbol is a closed circle, because an open circle means something else. Okay? So what I need you guys to remember, when you're adding, subtracting, multiplying, or dividing, the x values are not changing. Whatever was inserted as your x value maintains itself all the way through. In the next lesson it doesn't, so this is an important detail to attend to. So my h of x is going to be a product of f of x. If f of x is x minus 2 and g of x is x plus 2, when we multiply this, we would get x squared minus 4. This is fine for h of x. This is also fine for h of x. Factors will get me to my x-intercepts. Expanded form will get me to my y-intercept. Yeah? So if I want to get my x-intercepts, I'm going to go to the factored form. And I get x equals 2. I get x equals -2. I'm going to bring them back to ordered pairs. And I might even use function notation, because we're talking about f of x, and we're talking about g of x, and we're talking about h of x. It might be nice to distinguish where these ordered pairs belong, right? Like put it on h of x. Use function notation. When you are finding h of, so if I want to find my y-intercept, that's where x is equal to 0. Using function notation, we can see that h of 0 equals -4. If you think about this quadratic in terms of transformations, it was just a parabola moved down 4. Can you guys just imagine that parabola moved down 4? So when I plot these ordered pairs, and I graph my h of x, sorry, if this just does not want to go where I want it to. I'm going to try that again. There we go. Okay, so we had -2, +2 as the x-intercepts. I had 0 and -4. It should be obvious that these x-intercepts are equidistant from the y-axis, so that 0 and -4 would be your vertex, and I would graph my h of x. And label it as h of x, because we've already got an f of x and a g of x previously. So this lesson is not a huge stretch, right? State the domain and range of h of x. Your domain, let's do it in interval notation, would be -infinity to +infinity. And your range is -4 to infinity. Make sure that those are inclusive brackets. Kind of feels like a grade 11 question, right? Let's take it a little further. This one is grade 12. It's not hard. This will be a quotient. So guys, when we take a look at this guy, it's just a quotient we're dividing. So if h of x is equal to f of x divided by g of x, and I get this, it's just a rational. Okay? So here's my h of x. Let's actually do a quick sketch of this guy, because this is a review of rationals. We just had chapter 9 rationals. Okay? So if I were going to do a really quick sketch, because anytime I have a rational, I always want to come up with a sketch, because then I'm going to be sure about my domain and range. Yeah? No. We know that 2x minus 5 can never equal 0. So x can never equal horizontal. Okay, 1/2. Okay, thank you. Horizontal asymptote. So the degree on the top is the same as the degree on the bottom, so I know that it's going to be y is equal to 1/2. This one is going to be x is equal to 5/2. That's my vertical asymptote. When I say x-intercept, what do we say? What do we end up with? So if I put 0 in for the y, the bottom factor is eliminated by that 0, and I get -3 and 0, right? And then y-intercept, put 0 in for the x's, and you should have y is equal to -3/5. I'm just going to bring it back to function notation for these ordered pairs, okay? So I'm just going to bring this back to h of -3 equals 0. That's an ordered pair on my function. And then h of 0 equals -3/5. We're dividing the constant terms, and I put those zeros in for the x. So let's graph this function, just so that we can state the domain and range. So right away, we've got y is equal to 1/2. Degree on top was the same as the degree on the bottom. Label it. And then I've got the 5/2, which is going to be, and as long as I have a bit of a sense for where it is, this is going to be x is equal to 5/2. And then I've got negative 3 and 0. So negative 3 and 0 as my x-intercept. My y-intercept is 0 and like negative 3/5, which is telling me that I'm going to get infinitely close to the asymptote. I'm going to come around. And then you have to think about that rotational symmetry where the asymptotes intersect, right? Now the whole question is basically asking us what's the domain and range of h of x. So if this is h of x, how would I write the domain? And how would I write the range here? Zach, what's my domain?
X not equal y that.
Yeah. And then the range?
Y not equal 1.
Right. Okay, so guys, remember, your domain is always just all your non-permissible values. Your range is going to come from your NPVs of y, but it's going to come from horizontal asymptote and y value of point of discontinuity. If there's no y value of a point of discontinuity, it doesn't get listed. How does that look? Okay, do this one. This is a review of chapter 9. We just did chapter 9, so this should be an entire review. So if h of x is equal to f of x over g of x, please find h of x. Did you guys get that you end up with a point of discontinuity at 3 and 6? When you're determining your final equation for h of x, which is the quotient, you would say this: h of x is equal to x plus 3, comma, x can't equal 3. Like, this is a singular statement about your resulting h of x. Like, you actually have to perform the quotient, you actually have to do the division, but your graph has to include that point of discontinuity. And this is supposed to say graph singular, not plural. And again, even a linear function, you can find your y-intercept, right? So h of 0 is equal to 0 plus 3. So h of 0 is equal to 3. X-intercept. And these are always critical features. Make sure your point of discontinuity is clearly indicated. So when there's no factors left on the bottom, there's no asymptotes on the bottom. And the degree on top was greater than the degree on the bottom, so there's no horizontal asymptote. So now let's take a dive into domain and range. X such that x cannot equal 3. X is now a real number system. And then range, y such that y cannot equal 6. Y is now a real number system. So when you're actually, when you're just asked to graph the functions, when you're asked to just graph the rational, we often like kind of, and when we're developing the equations, we need to keep the point of discontinuity factors when we're developing the equation. This is actually asking for us to do the division. So we needed to actually do that cancellation, come up with our simplified h of x with the NPV, acknowledging that that's where the point of discontinuity occurs. Okay, so notice the difference. If I am saying, hey, develop the equation, you need the point of discontinuity factor included. If I say divide these, you're doing the division. So it depends on the question. Okay, check this question out. This is a conceptual understanding question. So it says, consider the graphs of f of x. The f of x graph here is in blue. And the g of x graph is in green. So, if h of x is equal to f of x over g of x, determine the critical feature that would take place on h of x at point A, point B, and point C. I just want you guys to read it, and I actually want you guys to try it. I'm not just going to give it to you. I want you to try this. It's a new way of interpreting the information that we've been studying and working so hard on. Could you put numbers in at point A, B, and C? Oh, hold on 1 second. Okay, so what if I did this? What if instead of A, B, and C, what if I called this -5, -4, and let's say this is 3? Yeah? Okay, let's look at f of x. F of x is going to have some a value. I don't know what it's going to be. But for my h of x, my f of x is going to have factors at x plus 4 and x minus 3. Do you guys agree? And then there's going to be some stretch factor in front, and it doesn't matter. Are you guys okay that these factors would represent my f of x? I should have done that in blue. I'm going to fix this. I'm going to color code this. Okay, so my blue function here has an x plus 4 and an x minus 3. And again, there's some number. I know it's a negative number, but it doesn't matter. There's some number in front that made it open down. That's my f of x. And we're asked to take f of x and divide it by g of x. So when I look here, this is x plus 5, x minus 3. Okay, let's think about this. The 3's came from point C. What's going to happen with the factors that are x minus 3? What critical feature will it be? Point of discontinuity. The factor was on the top and on the bottom. That's a point of discontinuity. Do you guys see it? If they share the same x-intercept, they share the same factor. Okay? What's this one going to be? So the -5, that's the A. So this was point A, gave us this factor. What's this one going to be? Vertical asymptote. That's the critical feature on h of x. What's going to happen at point B? This is the factor that came from point B. What does this factor give us? Say it louder, Brody. X-intercept. So guys, this actually comes back to, like, that's hard to interpret this properly, but if you give it numbers and if you give yourself something concrete to look at, you can make something of it. What this was really assessing is, do you remember that every rational function can have this form of x-intercept factor on the top, point of discontinuity factor on both top and bottom, and vertical asymptote factor? And then they were like, hey, do you recognize that this would be a polynomial divided by a polynomial, so it could be quadratic divided by quadratic? The numbers that are in front don't affect the critical features at all, right? I don't know what, and they didn't really give us enough information to determine what the a value was that was going to stretch it. There's not enough, because you can't develop the whole equation, but we can come up with the factors. Did you guys see that? So when you see something super abstract like that, you can throw numbers in there that seem reasonable and bring them back to the factors. So these would be your higher level questions. How about this one? Okay, so this is combining functions. There's a radical function that's f of x, right? And then we've got some sort of quadratic function. Guys, can I divide functions if it does not exist? Okay, so clearly my domain is going to start here because my f of x has a domain of x is greater than or equal to -3. So that's one piece. So when you're looking at your h of x and your h of x is f of x divided by g of x. Now f of x doesn't exist lower than -3, so we know this is going to have to be a component of my domain of h of x. But g of x is a quotient. It's got non-permissible values. Do you guys see that this is going to have NPVs on it? Okay, so if you actually brought it back, let's think about the factors. The stretch factor doesn't matter. We just know we can never divide by 0, right? So if we know we can't divide by 0, it doesn't matter what your f of x is. We've already acknowledged what that domain is. When you're looking at your g of x, on the bottom, I know that x plus 5 would be one factor. It doesn't matter what stretches it. There's a number here, but that doesn't impact the non-permissible values. And then x minus 4 will be the other factor. So here it says x cannot equal -5. Clearly, if we're greater than or equal to -3, we're already not going to equal -5. Do you guys get that? And then the other critical feature would be x cannot equal 4. So we have to put these pieces together for the domain of h of x. So the big idea for 10.1 and 10.2 is, can you really grasp the domain or the range of these given functions? So I'm just going to get my domain, and this is how you'd write it. You would say x such that x has to be greater than or equal to -3, because f of x was greater than or equal to -3. And then you would ditch this, because if we're greater than or equal to -3, we're clearly not going to be -5. Like this one, like from this point, like in this direction, didn't count, right? But we have to state x cannot equal 4. We can't divide by 0. So when you're thinking about whatever your f of x is, so this right here, whatever this is, whatever number it is, we can't divide by the 0 that's established here. A number divided by 0 is a non-permissible value. So you actually have to list your domain, including the restriction on the function that was in the numerator, and then the NPVs that were developed in the denominator. And those NPVs come from factors at the x-intercept. And this stretch of g of x does not change the x-intercepts. Guys, does this make sense to you, what we're doing, like with the, like that's the hardest piece of this, right?
What's the range?
Did I ask for range? No, then you're not gonna be asked for that, because we don't know, like we don't have enough information to get that, so don't worry about it. Okay. Given f of x is equal to x plus 1, g of x is equal to 2x plus 1, and h of x is equal to 2x squared plus 7x plus 3, determine each combined function and state its domain and range. Again, graphing these is always pretty handy when you're actually coming up with the domain and range. F of x times h of x. F of x would be x plus 1 times 2x squared plus 7x plus 3. This would be fair game for distribution, okay? So if I'm going to find my new function, I've got to take the x through every term. You would have done this in grade 10. So 2x cubed plus 7x squared plus 3x. And then I've got to take the 1 through every term. So plus 2x squared plus 7x plus 3. And when I put my like terms together, what type of function do I get? It's cubic. Tell me the story of this cubic function. By looking at it, what can you tell me about this cubic function? Okay. So guys, when you look at this, this would have had, like, this is actually factorable, which means there would have been 3x intercepts. But when you're looking at this, your function would have looked something like this. It would have been rising to the right. You had a positive leading coefficient. No, sorry. It would have been all negative x-intercepts. Because this is all positive. Like, if you would have fully factored this expression, I think you ended up with this. Y is equal to x plus 1. When you factor this trinomial, I think it's 2x plus 1, x plus 3. Let me just double check this. 2x squared plus 6x plus 1x, yeah. So then all of these are x-intercepts, and if you wanted to see that, well, you could type it into your calculator too, right? Like, this is going to be a rise to the right polynomial function, cubic function. Domain, let's do interval, negative infinity to positive infinity. Range, negative infinity to positive infinity. My leading coefficient is positive. I can see that my constant term is 3. If I would have factored, I would have had x-intercepts at negative 1. So I would have had like x equals negative 1, x equals negative 1/2, x equals negative 3. Like, this is just turning a linear times a quadratic into a cubic. And you need to remember that a cubic is XER YER. Okay. Handle this one. H of x divided by g of x. Remember, your ultimate goal is to get the domain and range, so having a sketch of your function is always a good idea. So guys, domain, we're going to have to use set. So x such that x cannot equal negative 0.5. X is now a real number system. And then the range, y such that y cannot equal 2.5. Y is now a real number system, right? Remember that points of discontinuity, the y value point of discontinuity becomes your non-permissible value for y. Does that look okay? Now, in terms of actually doing the quotient, I should have said this. Y is equal to x plus 3, comma, x can't equal negative 1/2 as a part of that. And then connect it to the point of discontinuity. And then from there, you get your domain and your range. So this is actually the quotient. You're actually going to do the division. Notice the difference between developing an equation from a graph and actually doing the division. Now these ones, you're given a number. When you're given the gift of a number, we get to use that number. So what we're doing here is we're finding f of negative 1 times g of negative 1. Brody, what's f of negative 1?
X squared plus
Okay, negative 1. So f of negative 1 is just like 4. If you're given the gift of a number, go straight to the y value that corresponds to that x value, right? And then g of negative 1 is 3. So this becomes 4 times 3, which is 12. So the ordered pair on the resulting function is negative 1 and 12. The x value is negative 1. The output becomes 12. Try f of 1 divided by g of 1. When you have the number, use the number. And just make sure you're putting them in the right order, right? Because order matters. So in this case, it actually doesn't. So f of, actually, yes, it does. F of 1 divided by g of 1 would be 4 divided by negative 1, which is negative 4. The resulting ordered pair on our quotient function is going to be 1 and negative 4. Do we feel okay with everything so far? I've got a lot of examples, a lot more than I thought we did. Oh, we're almost there. Okay. So again, we're finding a quotient, but this time f of x is a cubic function. We've got to fully factor our cubic function for us to do the division. So remember that when you're dealing with a quotient, you can have a polynomial on the top and a polynomial on the bottom. So if you're finding your h of x, and it's f of x divided by g of x, your h of x, we have to do the quotient. We have to fully factor the f of x, and we have to fully factor the h of x. How do we do that? That's chapter 3, and that was our first unit, right? So when I look at this, if I put a negative 1 in here, I'm pretty certain this is going to work out for us. No, it doesn't. Hold on one second. So negative 1. Yeah, it will. So if I put f of negative 1 into this equation, so negative 1 cubed plus 6 times negative 1 squared plus 11 times negative 1 plus 6. Now remember, you're typing this into your calculator and you're finding an x-intercept. Remember, that's how we type this into the calculator and you find your first x-intercept. I'm just being clever and I can see that it's negative 1. But this is polynomial functions, right? So I'll just do this for you. Like, this is what you could do if you couldn't see the negative 1. Right? Plus 11x, and then plus 6. There's my function. Oh, I've got like just such a nasty window, so I got to zoom 6 this. And I froze my calculator. I'm going to try again. Zoom 6. Okay, I see the negative 1. I trace negative 1. I get 0. Remember, you have to show me the remainder theorem in action. So this means x-intercept in function notation, which means x plus 1 is a factor. Your objective is to factor, so then we use synthetic division to find the remaining factors. Carry the one down, and honestly, like, you guys have to be with me on this, right? Like, this is not. And then we verify again. Oh, hey, there's my remainder of 0. So my first factor for f of x is x plus 1. My remaining factor is x squared plus 5x plus 6, which means we get x plus 1, x plus 2, x plus 3. So coming back to my h of x. The cubic function is x plus 1, x plus 2, x plus 3. What gives you a product of 2 and a sum of 3? Well, that's 2 and 1. X plus 1, x plus 2. All we're asked to do, oh, we weren't asked to do that. We were asked to find g of x. Oh, that's a bugger. I was doing f of x divided by g of x, and I was interpreting that. So this is not g of x. That was h of x. Can I just label these differently? Okay, I'll just show you what I'm going to do. I'm going to bring the g of x by multiplication and h of x down by division. Okay, so then g of x is actually f of x divided by h of x. This was h of x. Are we okay with that? I'm going to ditch this arrow. So if we're looking for g of x, which was the denominator, we would bring it up by multiplication. So now all I have to do, I misinterpreted. This is my h of x down here. This is still my f of x, and I'm actually looking for g of x. So I just had to solve for the g of x, and then I can divide all my common factors. Is that better? Now, technically, I should state the NPVs that are associated with that, because in the process, we had 2 NPVs. X could not equal -1 or -2. Just put it right next to your g of x.
This is h of x equals f of x divided by g of x. So you still have to divide it.
H of x is equal to f of x divided by g of x. This was h of x.
So x squared plus 2.
So, hold on. If h of x is, so if you wanted to do this, okay, so I would isolate for g of x first, if that's what I'm looking for. But you're saying x squared plus 3x plus 2 is equal to x cubed plus 6x squared plus 11x plus 6. Why wouldn't we just do this, right? So, and I should have done that right from the beginning. That's why I had to change this h of x. So the g of x is brought up by multiplication, the h of x is brought down by division. This became a g of x expression. Is that better?
Yeah,
Okay. Okay. Guys, try this one. Remember, when you're adding, subtracting, multiplying, dividing, the x values have to maintain themselves. This is a multiple choice question where these points are on p of x. The next list of points are on q of x, and you're supposed to find which point lies on p times q of x. Remember that the x values do not change. Keep in mind, these x values have to be the same. P of 4 was 1, Q of 4 was 3, and we end up with 3. Did you guys see that 4 and 3 would be on the resulting function? So A is your answer. If you would have done this one, there's no, like the 7 didn't appear anywhere. You do not multiply the x's. You're multiplying y's. This is saying when your x's share the same value and the x's do not change, right? They're both 4. They're always 4. Your resulting ordered pair is 4. You're just multiplying y's. This is saying multiply the y's when your x values are 4. A lot of people just want to multiply these and these. So a lot of people end up getting the 49 and 24. And then the 9 option wasn't even there. So we had the first answer. And remember, you have to feel comfortable with ordered pairs. You have to feel comfortable with the table of values. And you have to feel comfortable with a graph. So if I say h of x is equal to f of x divided by g of x, keep in mind all of these x's are the same thing. What do we need that thing to be in this question? 3. Put it in. So if I'm going to find h of 3, and that's going to be f of 3 divided by g of 3, what's f of 3? What's g of 3? Thank you. That took a little while. So h of x will have the ordered pair 3 and 6. So h of 3 is 6. Done. Second lesson is finished. Monday I'm checking homework for everything chapter 10 because I've checked everything from, so Hannah, I still have to check yours from rationals. Okay, so this is your homework. Tomorrow's lesson gets a little tricky. There's an element that just like domain and range, that gets tricky here, right, is coming up with domain and dealing with all restrictions. So those can get tricky. Tomorrow we're going to be doing composite functions. So what I want you guys to do is just working together, working independently, work on that chapter 2, 9, and 10 assignment again, and just keep on firing through that. And this homework I'm checking on Monday. So the plan is, Monday you have a quiz. I will be here in the morning so that I can mark that quiz and have it ready for you to get back the next day. And then I will give you an assignment to work on Tuesday.
I have a question.
Yes, go ahead.